Okay, so let's start with the chapter 7 challenge problem. So let's see the first one, the angle bisector of, okay, we have a triangle GHI, and the angle bisector of G is alpha, and alpha is also passing the circumcenter. So we want to show the GH is equal to GI. So let's do the height. Okay, so we call it M and N. So because the O is the intersection, right, of perpendicular bisector, right? So I mean, if this is the perpendicular line, right, we do the OM perpendicular to GH and OM perpendicular to GI, and the O is circumcenter. So by 3 we know the M and N are also midpoint, right, because the OM and ON are the perpendicular bisector. So now we know this equals this, this equals this, right? Then we have the GI is 2 times the GN, and the GH is 2 times the GM. Okay, so the goal, I mean, if the GI equals, if, right, so if we prove the GM equals GN, we can do this, right? So the GM and the GN, right, if you see it very clear, because you know it's the angle bisector here, right? So you know we have the angle, and OG is the common side, right? So the triangle, the GNO, and the triangle, the GMO. So you know it's GO equals GO, right? You know the alpha equals alpha, and you know the 90 degree equals 90 degree, right? So you know these two triangles are congruent. If they are congruent, so now you can see the GN equals the GM, right? That's it. Next. So let's assume the H and O denote the orthocenter. So we have a triangle ABC. Okay, and we know the O. We know the O and the H are we know the O and the H are the circumcenter and the orthocenter, right? So the AH meet BC at P. So the AH meet BC at P. Then the AO meet BC at Q. So we want to prove the BAP. We want to prove the BAP is equal to the CAQ. Okay. So now let's see. Let's see what is the BAP. Okay. Since this is the H is the orthocenter, right? So we know the BAP is equal to the 90 minus B, okay? Because we have a right triangle here. Okay, so now we can see the CAQ, right? So the CAQ, let me use another color. So the OA is equal to OC equals R, right? So now you know the B is the inscribed angle, right? And the AOC is the centric angle is equal to 2B, right? And then you know, because this is the isosceles triangle, right? So now you know the Q is CAQ is equal to 90 minus the B, right? So this one also 90 minus B, so you know they are equal. Okay. And the next one. So we have a triangle JKL, and JK equals JL. So we have 25, 25, and 40. So find the following things, okay? So the first is what's the area of the JKL? So this one is simple. So because this is the isosceles, so once we let down the midpoint is also the height and angle bisector. So here is 20, here is 20. So this is 5 times 5. This equals 5 times 4, right? So it's basically the 3, 4, 5 and scaled by 3, 4, 5 right triangle scaled by 5. So this is the 15. So it's easy to solve the A. It's half of the 40 times the 15 is 300. Okay, now B. So the in radius of the JKL, right? So let's see. Here is the in center of the eye. So you can see we have the 3 of the median. This is the R, this is the R, this is the R, right? So we can cut this triangle into 3 parts, right? It's JIK, KIL, and JIL, right? So we know the triangle, the JKL is equal to 3 parts, is the JIK plus the triangle, the JIL plus the triangle of the KIL. So this one is half of the 25 times R plus half of the 25 times R plus half of the 40 times R. So you can see it's half of the the perimeter. Right, this is the half of the perimeter times R. And we already know this one equals 300. Using this way, we can solve the R is equal to the 300 over 25, 45 is equal, last piece, C. Okay, so what is the circum radius of this triangle? Okay, so the circum radius is this is the perpendicular bisector, and this is another perpendicular bisector, right? So the circum center of this is O. Now we can apply the let's apply the law of sine at triangle. Okay, so we know the 2r is equal to the jk over sine L, also equal to the JL over the sine K, or we have the KL over the sine J, right? And then we know the sine K is equal to the sine K is equal to the opposite side divided by the hypotenuse, right? So it's equal to the 15 over 25 is 3 over 5. So now we know 2r is equal to the 25 over 3 over 5. Then we can solve the r equal next. Okay, let me prove something. Okay, let me prove the law of sine. Okay, so we have a triangle ABC. This is the A, this is the B, this is the C, right? So this is the circumcenter. So we can draw a line here. Okay, let's see, this is the P. Okay, and then we know the BP is diameter on the circle O, right? So now you know this angle is 90 degrees. This is the 2r, right? BP equals 2r. Now we can have the arc BC, right? So the BC arc span the angle here, inscribed, also inscribed the angle here, right? So this is the angle of the BC arc of the centric angle. So now you can see this angle should equal to this angle spanned by the arc of the BC. So that's why this is the angle A. This is also the angle A, right? Now we know the A. Okay, you can see this is the right triangle. This is the opposite side. This is the hypotenuse. So A over 2r is equal to sine angle BPC is also equal to sine A. And that's why we have A over sine A is 2r. Okay, so this is the extended law of sine. Then so that's why we have A over sine A equal to B over sine B, then equal to C over sine C equals 2r. Next, let I be the incenter of the triangle ABC. So this is the incenter of the triangle ABC, and this one over the of the A prime. Okay. So for the incenter, okay, there is a angle. This is the angle bisector, right? So there is the angle bisector theorem. The angle bisector theorem is easy to calculating using the area. Okay, so it's the ABC, and this is the angle bisector of the CD. Then what we have is the AB over AC is equal to the BD over DC. Okay, but it's easy to calculate. For example, this is the alpha, this is the alpha. Okay, so the triangle area, okay, the area of the triangle ABD is equal to half of the AB times AD sine of the alpha. Then triangle ACD is equal to half of the AC times AD then sine alpha. Then you know the ratio of the ABD over the ACD is equal to the AB over the AC, right? And also if you see you length a height, right? So this is the H. The ABD is also equal to half of the BD times H. This is also equal to half times CD times H. So the ratio of this is also equal to BD over CD. Then you can have this angle bisector theorem. Okay. So now, because this is the angle bisector, right? And this is also angle bisector for the in-center, right? So what we have is the AI and the IA prime, right? AI, IA prime, because in the triangle of the AB, A prime is equal to AB over A prime B. Okay, so that's what we of the A. You inverse it, you can prove. Okay, now the second one is the same thing. Let's draw a one here. So we have the gamma and the gamma. So in the triangle A prime C, okay, so it's also the AIB over IA prime is equal to the AC over the A prime C. Then let's flip it, right? So we have the IA prime over the AI is equal to the A prime B over AB. And this one is IA prime over AI is equal to the A prime C over AC. Now we have the, from this two, we have the IA prime over AI is equal to the A prime B over AB equal to A prime C over AC, right? We talked about this before. You can, this one you can do AB plus AC, then add them up, A prime B plus A prime C, right? And so it's AB plus AC, then it's BC, okay? Then 754. So we have a triangle of A is 100, B is 50, so the ABC, okay, so we have the 100, we have the 50, we have the 30, and the H is on BC and M is on AC, such that AH is the altitude and the BM is the median. Okay, so this one means this is the 40 degrees, this is the 60 degrees. So what it asks us to find the angle CH MHC. Okay, so it asks us to find the angle MHC. So Let's see. So we have the altitude 40. Then we have the median. Okay, done. You can see here. Is this a right triangle? Okay, if this is the right triangle, means if I have a circle, right? If I have a circumcircle, okay? So AC is the diameter of circumcircle of triangle ACH, the ACH, and this is the median, right? So we have the AM equal MC is equal MH is equal to the radius of the R. Okay, that means this one equal this one, right? So this is a 30. So that's why the MHC is 30 degrees. Next. So is it possible for the two angle bisector to be perpendicular? Okay. Let's see, we have a triangle, right? ABC, and let's see the two angle bisector is perpendicular. Okay, let's see this two are perpendicular. Okay, this is the alpha, and gamma, right? Let's see they're perpendicular. So now we know if alpha plus the gamma is the 90 degrees. So the 2 alpha plus the 2 gamma is 180 degrees. But 2 alpha is this, right? Is the A and the C. So 2 alpha plus 2 gamma plus B is equal to 180. That means that B is equal to 0 degrees. But 0 degrees is not a triangle, so there is no. The answer is no. Okay. So next. So in triangle ABC, the C is the right angle. ABC. C is the right angle, and M is the midpoint of AB, and N is the midpoint of the AC, and the point O is the midpoint of the AM. Okay, so this AM is the midpoint, N is the midpoint, right? Means the NM is perpendicular and equal to half of the BC. Okay. The perpendicular, the perimeter of the ABC is 112. So P of the ABC is 112, and ON, and this is 90 degrees, so this is also 90 degrees, and the ON is 12.5. So you can see this is the right triangle. Okay, the AM is the diameter, so that's why we know this is 12.5. So AO equals OM equals ON will be equal to the 12.5. Then we can know the AM is equal to 25. Then M is also the center. We know the AB is equal to the 50. So this is the 25. 12.5 and 12.5. Okay. Then we know the perimeter of the ABC is 112. So the AC plus the BC is 112 minus 50 is 62. Okay, so it lets you calculate what is the area of the MNCP, MNCB, right? Okay, so we can see the triangle A and M is a quarter of the triangle ABC. Then we see the MNCB will be 3/4 of the triangle ABC. So now if we solve the triangle ABC, right? Then we solve the area of the MNCB. So now let's see this is the B and this is the C. Okay, so we know the B plus C is equal to the 62, and also B squared plus C squared is 50 squared. Okay, and the area of the ABC is the half of the B times C, right? Okay, so from 1 and 2, the goal is to solve the B times C. So the 1 square is B plus C of the square is equal to the 62 square is B square plus C square plus 2BC. Then we have the 50 square is the B square plus C square. Now we can solve the BC, okay? So the BC, B times C is 3 times 112, okay? Let me see. B times C is the B2BC. 2BC is the 62 square minus the 50 square is equal to the 12 times 112. Then BC is equal to the 6 times 112. Then we see the half of the BC. The half of the BC is equal to 3 times 112. Then we know the MNCB is 3/4 times 3 times 112 is equal to is 2. Okay, next. So this is the x-center of a triangle. Okay, so let's talk about the x-center. So if we have a triangle ABC, like we did here, right? So the x-center is the angle, is the intersection of the angle set bisector of the exterior angle of the B and C. Let's see, this is the B. Let's see, this is the P. So because this is the angle bisector, right? So we draw the two perpendicular lines. Here is the X, here the Y. Okay, here is the 90 minus B, B over 2. Here is the 90 minus B over 2. So these two angles are same, right? The same. So that's why you can see, and also this is the angle bisector. So we know the triangle, the BYP is congruent to triangle BXP for the side angle, right? So we have 90 over 90. We have the 90 minus B over 2 compared with 90 minus B over 2. Then we have the BP equals BP. So this is the AAS. Okay, you can see these are two congruent. Then we prove this side equal to this side. So then you can see the PY equals PX. Okay, so the same reason, this is the Z. So this is the 90 minus C over 2. This is the 90 minus C over 2. The same reason you can prove the PX equals PZ. Now combine them together. You can prove the PX equals the PY equals the PZ. Okay. So that's why we proved the P has the equal distance to the AB extension, BC, and the AC extension. Okay. Let's see, this is the RA. Okay. So in the next problem, next half of this problem, we will also use this picture. So this is the IA, right? This is the X radius. Okay, so that's why we already proved this, and we want to prove IA is lie on the angle bisector of the A, right? So let's see. Let's connect it. Okay, so this one is 90 minus B over 2. This one is 90 minus C over 2, right? So remember, we already proved the Z and the X are equal. So we know the triangle APX and the triangle APZ, right? We have the 90 degree equals 90 degree, and we know the PX equals the PZ, right? And we also know the AP equals AP, right? Because this is right triangle, Pythagorean theorem tells us the AZ, the AX equals AZ as well, right? The AP square minus PX square root. So that's why. So according to SSS, these are congruent. So that's why you know this angle is alpha, this angle is alpha, right? This is A over 2, this is the A over 2. So that's why you know the angle XAP equal to angle ZAP is A over 2. So the final question is let you calculate the RA, right? This is the RA. So when we calculate the RA, we need to see the area of the triangle, okay? We see this triangle, okay? So the area of the ABC is equal to the area of the ABP plus the area of the triangle ACP minus the area of the triangle BPC. So you can see the ABC, right, is equal to these two. So this one is half of the C and B and A, right? So this is the half of the C times the RA plus half of the B times RA minus half of the A times RA. Right, so you can see it's half of the A plus B plus C then times RA, then minus the A times RA. So this is the S, right? Half of the perimeter. So S minus A over RA. So that's why you can see the RA equal to the triangle ABC over the S minus A. Okay. Next. So the point M and N are the midpoint of the PA and PB of the triangle APAB. PAB, M and N. Okay. As P move along a line that is parallel to AB. So now we know the M and N. Equal and perpendicular to half of the AB and also perpendicular to the line M. Okay, so we want to the length of the once the P is moving on this, the length of the segment MN, right? MN is half of the AB. We didn't move in the AB, right? AB is fixed. So no change. B, the perimeter of the BAP, right? So it's the AB plus the PA plus the PB. Of course, I mean, you can see if we P goes to extremely goes here and infinity, so this one goes to infinity, right? So then here is not infinity. So that's why this one is changed. C, the area of the PAB. So the area of the PAB is the distance is h. So the PAB is equal to half of the AB times h, right? Since the two parallel lines, so the distance between the AB and M are constant. So the h is fixed. And the AB is fixed. So this is fixed. Last one is the area of the ABNM, right? The ABNM, like what we did before, is 3/4 of the triangle ABP. So the MBP is fixed. So this one is also fixed. D. Okay. So we let the triangle XYZ have the x equals 60 and y equals 45. And a circle with the center P pass through the AB on the side of the XY. Okay, and okay, so we have a circle passing these 4 points. Okay, AB, CD, and EF. Okay, so we know the ABCD are concyclic. Then we have the AB equals the BC. Okay, so we have the circle passing all through of them, right? So now we know the center of the O is the intersection of the 3 perpendicular bisector, right? The perpendicular bisector of AB and CD and EF is the center. So prove the P. Okay, center is P. Prove the P is the in-center of the XYZ. Okay, so because this is the hexagon is concyclic, right? We have the AB equals BC. So let's see. This is the T over 2. This is the T over 2, right? This is the T over 2. This is T over 2. This is T over 2. This is T over 2. Let's parameterize it. Okay. Then we have the so we know the radius is R. I mean the center to the radius is R, right? And the center to the center point to the distance from the P to the AB is X. Okay, so the X is equal to the R square minus T square over 4 square root, right? So you can see that's why all these distances are the same, because it's R is T is the same, right? So now we know the PMN R. Okay, so we know the PM equals to the PN equals to the PR, right? Where PM, PN, PR are perpendicular to side X, Y, Y, Z, and ZX respectively. Okay, now if we know this, now let's highlight it. Okay, so we know this equals to this, right? Now let's add this line. Okay, so we know this equals this, and the XPX equals PX, right? Let's write triangle the MPX and the triangle RPX, right? PX equal PX, then PM equal PR, right? And the 90 degree is equal to the 90 degree. Okay, this means the XM is also equals to XR. So according to SSS, right, we know the triangle, these two triangles are congruent. If these two triangles are congruent, then we know the angle MXP is equal to the angle RXP. Okay, similarly, okay, we can prove also the PY bisect angle Y. So this two angle bisector, right? So we know P is in center. Okay. So the next question is let us to find the angle of the XPY. So this is simple, right? You know this is 30. This is the 45 over 2. Then the angle of the XPY is equal to the 180 minus 30 minus the 45 over 2. So this is the 255 over 2. Next. So a ladder is initially rest vertically, right? Okay, we see this problem before. Here's the ladder. This is the ground, right? So the ladder is, this is the perpendicular. So the ladder is initially due here. This is the L. Okay. And but it's moving, right? When you go on the ground, so it's moving from the here. The other side is moving along the ground, right? So the doesn't change is the length of the ladder doesn't change, right? So it's A, B, and CD. So we know the AB equals CD equals the L, right? And this 90 degree doesn't change. So the question is asking us to see what is the midpoint of the M and N. So the question is asked, so what is the path of the midpoint of M and N, right? So take a look at the right triangle of the AB. ABX, okay? So you know this is the midpoint, right? So you know the XM equal to half of the AB equal to L over 2, right? Similarly, you can see the XN is equal to half of the CD is L over 2, right? So that means the midpoint of the M and midpoint of the N, okay, to the X is a constant distance. So that means all the midpoint are on a circle, right? So the midpoint should be on the circle in using the X, and the radius is L over 2. Okay, these are the path of the midpoint. Next. So the triangle ABC, and that P is the midpoint of the median. So AM is the median. Means these are the midpoint, and the P is the midpoint of the median. Okay, and let N be midpoint on the sides AB. And if G is the intersection of this, okay, so you can see for triangle ABM, right, we have two median, the MN and the BP are median, and intersect at G. So you know the ratio of the BG is 2T and T, right? Now we can see the area of the MGP, right? So the area of MGP is, this is this is 1, right? And this is the 3. So we know it's 1/3 of the triangle and the BMP, right? So the area of the triangle BMP is half of the triangle. So is half of the triangle of the ABM. And the area of the ABM is half of the triangle ABC. So this one is 1/12 of the triangle ABC is 48 over 12 is 4. Next. So this problem we want to prove the median of the triangle are concurrent. Okay. Yeah, maybe I didn't quite follow this one. Let you see A, B, C. Okay. Then we have the D and the E are the median. Okay. So what we want to prove, let's see, this is the F, right? We want to prove, okay, in order to prove the CG, in order to prove the CGF collinear, okay? Let's see the F is midpoint. Okay, you need to intentionally, okay, draw the FG and the CG not on the same line. Okay, you need to intentionally not draw on the same line, and then we prove they are collinear. Okay. So see, if we want to prove it is collinear, right? So the good way is to prove the triangle FGC is 0. If I prove the area is 0, that means it's degenerated, right? So means the FGC is collinear. Okay, now let's prove it. So we can see the S triangle FGC is equal to the triangle of the AFC minus the triangle of the AFG minus the triangle of the ACG, right? Let's calculating all this in terms of the triangle ABC. Okay, so let's see the triangle AFC, the AFC, right? AFC is half. AFC is half of the triangle ABC. Okay, the triangle AFG. So the AFG, right? Okay, so the triangle AFG, you can see, so this one is the because this is equal to this, right? So it's half of the triangle ABG, right? Then the triangle ABG is also this is the 2, right? This is the 1 T and 2T. So it's a 2/3. Is the 2/3 of the triangle ABD, right? The triangle ABD is half of the triangle ABC, right? So now we see this one is 1/6 of the triangle ABC. Last piece, ACG. Triangle ACG. the ACG is here, right? So it's a 2 and a 1, right? So the ACG is 2/3 of the triangle ACD, and the ACD is half of the triangle ABC. So this one is 1/3 of the triangle ABC, right? Now let's calculating the FGC. So triangle FGC is equal to the half of the triangle ABC minus the 1/6 of the triangle ABC minus the 1/3 of the triangle ABC is equal to 0. Okay, this is what we want. So that means the CFG have to be collinear, right? If the CFG has to be collinear, right? CFG is collinear, that means the CF also pass the centroid G. Okay. Next. So the point N is on the hypotenuse of the let's see. So it's the ABC. Okay, so this 6, this is the 8. Find AN. So the CAN. So this is the 45. This is the 45. So this is the AN is the angle bisector, right? So if AN is the angle bisector, you know the CN over NB is equal to the 8/6, so equal to the 4/3. So that means also the BC, this right triangle is 6, 8, 10, right? So the BC equals 10. The BC equals 10 equal to, we cut into 7 pieces, right? This is the 4/7 times 10. This is the 3/7 times 10. Okay. Do we want to find what is the AN, right? In order to find the AN, let's land the height, AH, okay? If we solve the AH, we solve the NH, we solve the we can solve the AN, right? So let's using the similar triangle, okay? The similar triangle here is the BH. We have a law, okay? So the AB square, this is based on the same thing. BH A is similar to triangle. The BHA is similar to triangle the BAC. Then we have the AB square is equal to the BH times BC. So that means the BH is equal to the 6 square over 10 is equal to the 5/18. So we solve the BH, right? And we know the BN is 30/7, right? Now we can know the NH. The NH is equal to the BN minus BH, right? So 7/30 minus 5/18 is equal to the 35, 150 minus. Okay, we solved the NH, right? Now the other thing we need to want to solve the AH, okay? So it's the same thing. We know the AH square. we know the AH over 6 is equal to the 8 over 10. So we know the AH is equal to 10 over 64 is 524. Okay, then the right triangle ANH, we solve this one, we solve this one. Now it's easy, right? So I will leave the last calculation for you, okay? So the AN is equal to the AH square plus the NH square. We have the NH here, we have the AH here, okay? Last one. So the circle at right, okay, so we have a circle and we have an equilateral triangle. If X is the midpoint of AC, so if X is the midpoint, right? So for the equilateral triangle, we know X is also the angle bisector. So here is the Y. We also know this arc, the CY arc, equal to the AY arc is equal to 2 times the 30 degree is 60. Okay, these are all the property of the circle. Then if X is the midpoint and the Y is on the arc AC such that the, okay, so this is the 90 degrees, right? So we know the BX is also the 90 degrees. So that's why is BXY is collinear. Then find the length of the XY. Okay, we want to find the length of the XY. So now we know the length of the BY is diameter, because the circumcenter is here, okay, is equal to 2. Okay, so if we solve the BX, now we can solve it. The BX, because the ABC is the equilateral triangle, so BX is the root 2 or root 3 over 2 times the BC. Okay, so what is the BC? Okay, so we know this is the 60 degrees, right? So the BC arc has an inscribed angle of 60 degrees, and also this is the 60 degrees, and the BY is the diameter, so this is 90 degrees. So now we can see the triangle BYC is the 30, 60, 90 degrees, and we have this one is 2, so the BC is the 2 times the root 3 over 2 is root 3, right? So BC is root 3, so this one is the root 3 over 2 times root 3 is 3 over 2. Okay, so we know that XY is equal to the BY minus the BX is equal to 2 minus 3 over 2 is 1 over 2. Okay, so that's it for this chapter's problem. Thank you.